ANTstein Square is a full-stack, integrated automation platform designed to provide straight-through processing. While it can be used as a platform with its integrated strengths, it can also be consumed via independent modules. This demonstration will show how AntStein Square's CMR module provides a seamless solution to extract and curate data from a typical accounts payable process and hands it over seamlessly to the QueenBOT to post it into the transaction system, completing an end-to-end accounts payable transaction. The CMR uses key pair learning technique to extract data fields from label, header, or line item details. Let's take a closer look at how this module works. The process begins with client or department creation and process creation. This is done by entering the appropriate structural aspects of the document for data extraction. Note that we will use a single sample invoice to configure patterns and define the data extraction process. With the document ready for defining the process, we will then configure 4 header fields for extraction using one of the data hunting techniques. The headers, which we will define here, are invoice number, invoice date, order ID, and amount due. Notice that we didn't define the content position of the data points. Instead, we let CMR decide which part of the document this information can be retrieved from. Similarly, we will configure line items such as cost and description using one of the data hunting techniques. Unlike the header label, the content position for line item extraction is referenced as below the label. This is to ensure that the engine understands that the only information to be picked up are those below each respective labels, such as cost and description. Configuring the line item in this manner ensures that all line items which could be available in multiple pages of the invoice copy are captured sequentially. We will also toggle or change the data field property from header to line item as part of the field definition. We finish the configuration process by defining a business rule. For example, we will change the format in which all invoice data to be captured as DD, MM, YYYY and save the same after validation. Similarly, other business rules can be defined to suit your requirements, such as math rule, special rule, and concatenate rule. CMR pulls up the remaining batch files and completes the training process. The Quality Analysis for Training function allows us to perform quality checks to see if the data elements have been captured correctly. A corresponding confidence score based on the curation of the data will then be assigned: correct in green, modified in blue, doubtful in yellow, and no data in red. We can observe here that on certain samples the order ID as well as the line items are not extracted. This is because some of the header items have different names compared to the ones that were used during process setup. We shall perform manual quality check to recalibrate these data points and add these aspects to the knowledge base as part of the training to ensure that future invoices of this format recognize the additional data field as well. The samples are once again processed to determine if the training was successful. We can see that this time around, all the data fields are extracted accurately. Hence, the training process is complete and the build is concluded. The digitized data is now available for exporting in the desired format. The QueenBOT module completes the final stages of the invoice processing, ensuring a truly end-to-end process automation. The bot is calibrated to pull up the folder in which invoice data are shared. With all the available information, the QueenBOT accesses the source ERP system and uploads the extracted data into the accounts payable system, completing the whole process. ANTstein Square's invoice processing solution significantly reduces the time and effort you need to process your invoices, resulting in cost savings and more efficiency for your business.